Good morning, students. Welcome to day 3 online class of mathematics for class 10, that is chapter 1 real numbers. Let us once recall yesterday, day 2. What do we discuss yesterday? We discussed yesterday based on fundamental theorem of arithmetic and rational numbers and their decimal expansions. Did you all complete yesterday's homework? Very good. Thank you. So, let us start the class for day 3 with theorem number 1.6. We don't want to bother about the proof. Just we want to go through the statement only. Let P be a prime number and A is a positive integer. If P divides A square, then P divides A also. This is a small theorem. Let me go through some examples. Here 2 is a prime number. 2 divides 4 square. 2 divides 4 square or not? 4 square value is 16. 2 how many times possible in 16? 8 times possible. Which implies 2 divides 4 or not? Yes, 2 divides 4 also. Let us go through one more example. 3 is a prime number. 3 divides 6 square, which implies 3 divides 6 also. Let us go through the applications of theorem 1.6. So actually we have seen the two examples from the above. 2 is a prime number. 2 divides 4 square means 2 divides 4 also. In the same way, 3 divides 6 square means 3 divides 6 also. Here, the first question which was given to prove that root 7 is an irrational number. Of course, we know root 2, root 3, root 5, root 7, these are all the irrational numbers. But here we want a rigorous proof. So let us see how can we prove this root 7 is an irrational number. Actually, in our 9th class level also, we have seen some proofs which are based on direct method of proof, and some problems we may prove like indirect method of proof. If we go through direct method of proof, there is a particular process to prove the given question, or we want to use a particular formula to prove the given condition. And some problems in mathematics particularly, there is no particular process was given to do the solution. So in such cases, we would like to go through the controversy method. See, which happens sometimes usually in our classes also, in our daily life also. Let me explain in detail. For example, I don't know anything from one particular issue. When someone is saying and someone is explaining about that topic, simply like a fool, I am blaming everything. That is wrong, that is wrong, that is wrong. After some time, most of the people they came to know, oh, Mr. Kiran is simply arguing, he doesn't know anything. Then when I observe from this situation from the people, what I will do? I will accept my mistake. Oh, sorry friend, I did mistake. So that is the case. I told what you are saying that is wrong. Why I told like this? It is a blunder mistake. Okay, leave like that. So finally, what I would like to conclude is what you are saying that is correct. So I can't do anything, no, because I don't have any information among that term. So this question also we would like to prove by using indirect method of proof. Means by using controversy method. Let us go through the solution. Let us assume root 7 is a rational number Actually, what we are asking to prove? We are asking to prove that root 7 is an irrational number. So blindly we have to assume that root 7 is a rational number. Means what? We are doing in something. And finally, we may get some confusion. That confusion is nothing but a contradiction. At that situation, we are helpless. We can't do anything. At that situation, we will agree our mistake. So in the same manner, we are going to prove this. When we assume root 7 is a rational number, can we write root 7 as p by q, where p comma q are co-primes? So now, what I am doing here? Squaring on both sides. Root 7 whole square is equal to p by q whole square. We know square and root will be cancelled. 7 is equal to p square by q square. If q square comes to LHS, 7q square is equal to p square. From this, what should I say? Q square is equal to p square by 7. Let us recall once theorem 1.6. What do we discuss in the morning itself? If 2 is a prime number, 2 divides 4 square, then 2 divides 4 also. We use that condition here also. Here you see 7 divides p square, which implies, according to by using theorem 1.6, can we say 7 divides p or not? Yes. 7 divides q square, which implies 7 divides 7 divides p square, which implies 7 divides p also. How we know this? Theorem 1.6. From this statement, we came to know 7 is a factor of p. Say this is first equation. Actually, what we consider here, root 7 is a rational number. That means root 7 is equal to root 7. We would like to equate p by q. Here p and q are co-primes. Here we get 7 is a factor of p. So something we get till now. Let us go through the rest of the proof. What can we do now? Here, put a is equal to put p is equal to 7c or 7x or something. Something we have to substitute in place of a numerator. And what will happen, you see here. Root 7 is equal to 7c by q. Again, what I am doing here, squaring on both sides. So, root 7 whole square is equal to 7c by q whole square. See this, what will happen? Square root will be cancelled. 7 is equal to 49 c square by q square. Now, 7q square is equal to 49 c square. Here 7 times possible. Yes or no? So now from this we get q square is equal to 7c square. How better you go through this step again. How we wrote 7 q square is equal to p square. From this, the value of q square is equal to p square by 7. So in the same manner, may I write q square by 7 is equal to c square? Means it is nothing but if 7 comes LHS, 7 divides q square. Again by using theorem, 1.6. Again by using theorem 1.6. 7 divides q square, which implies 7 divides q. Theorem 1.6. Therefore, 7 is a factor of q. Say this is second equation. Here you see, if you go through the first part of the proof, according to the first equation, we know 7 is a factor of p. And by using this condition, here we came to know 7 is a factor of q. So let us use those two conditions. From 1 and 2 conditions. First condition says 7 is a factor of p. Second condition says 7 is a factor of q. That means from these two conditions we get a conclusion. From 1 and 2, 7 is a common factor of both p and q. Once go through our assumption here. Let us assume root 7 is a rational number. When we assume root 7 is a rational number, here we took root 7 is equal to p by q, and within brackets we wrote p and q are co-primes. What is meant by co-primes? The numbers which have only one is the common factor are known as co-primes. But how it is possible? Here we came to know from the conclusion 7 is a common factor for both p and q. But here our assumption is p and q are co-primes. If 7 is said to be a common factor of both p and q, we should not say p and q are co-primes. So here we get a contradiction. Why we get a contradiction? Because of our wrong assumption, which is contradiction. So our assumption, what is our assumption? Root 7 is a rational number. Our assumption is wrong. Therefore, root 7 is an irrational number. If suppose in place of root 7, root 2 is given, we can prove like this. But when we go through the second part, instead of p, here we took 7c. If root 2 is given, put p is equal to what value we are going to substitute? Yes, to c we have to substitute. Instead of c, you may take x or something, any other variable you can take. So this is the controversy method. 7 is a common factor of both p and q. So which contradicts to our assumption? So our assumption is wrong. Therefore we conclude that root 7 is an irrational number. So this is the first sum is over. Let us go to the second question. Prove that root 3 minus root 5 is an irrational number. So how can we prove this question? Let's see. How will we write the solution for first sum? In the same manner, we would like to prove in controversy method. Let us assume root 3 minus root 5 is a rational number. How did we take our assumption in the previous question? In the same manner, we would like to take root 3 minus root 5 value is a rational number. That is, root 3 minus root 5 is equal to p by q, whereas p comma q are co-primes. Now, what I am going to do is see. Actually, in the above question, of course, only one term is given, root 7. So there we did squaring on both sides. Here also we will do the same thing. Squaring on both sides. What will happen, you see? Root 3 minus root 5 whole square is equal to p by q whole square. Can we expand LHS is in the form of a minus b whole square? Any one of you can say the formula for a minus b whole square? Right, a square minus 2ab plus b square. Of course, that is a familiar formula. So here we use a minus b whole square is equal to a square minus 2ab plus b square. By using this formula, expand LHS condition. Root 3 whole square means we consider root 3 as a and root 5 as b. So instead of a minus b whole square, we want to use these three terms. That means instead of these two terms, we use this expansion. So first, in the right hand side expansion, what term which was present? A square. So at first we want to write the value of a square. Root 3 whole square. Now a square after what symbol is there? Here most of the students they are doing well, but where you are doing mistakes, according to my knowledge, you are not focusing on using the symbols properly. So take care about these symbols. So once we are using a minus b whole square, before the second middle term, we should get negative sign. If we are using a plus b whole square, everywhere in the expansion, positive sign only we will get. So let us concentrate on those symbols. Root 3 square, here minus 2 is there, so that's why I am also writing minus 2. Minus 2 after what we should write? A. A value is what? Root 3. Next, b value is what? Root 5. Next, plus symbol is there. B square value is root 5 whole square is equal to, what is the RHS value? B square by b square. We know the square and root will be cancelled. This value is 3 minus 2. We know the properties of irrational numbers. What are they? Root a into root b is equal to root a. That means instead of writing separate square roots, we may write it as only one square root, and we multiply these two terms in one square root. You will also do the same here. 2 times root of 3 into 5. 3 into 5 plus 5 is equal to b square by b square. See, except the middle term, there is no root symbol which was present in the first term or as well as the last term. Can we add these two values? 3 plus 5 is 8 minus 2 times of root 15 is equal to p square by q square. P square by q square. And now what will happen? You see. Can we interchange these two terms? For example, you say, boy, you and you, both of you can interchange your places. Means what does it mean? He has to go for the second bench, and the person who sits on the second bench has to come to the first bench. Here we need not to change the symbols. Yes or no? When this minus 2 root 15 will goes to right side, it becomes positive value. In the same way, p square by q square comes to LHS, it becomes a negative value. Here you see what will happen. 8 minus p square by q square comes to LHS. P square by q square is equal to 2 times root 15. Means we interchange these two values only. So better we find the LCM. LCM is q square. So q square has to multiply with 8. 8 q square minus p square is equal to 2 times root 15. Here there is a chance to do a mistake by some students. Simply without seeing properly the steps. Some students, what you are doing now? Sir, can we cancel 2 4s? How it is possible? If suppose 8 q square is multiplied with p square, that means 8 q square and p square becomes entire term becomes a one term, we are able to do the cancellation. But when this splits as two terms, we should not do the cancellation. So don't do the mistakes again and again. So that is the case. Send 2 into RHS. When 2 comes RHS, it goes to denominator part. 8 q square minus p square by 2 comes to denominator. 2q square is equal to 250. Here you observe the conditions which was present in both LHS and in RHS. If you observe LHS condition, 8 or q square or p square or 2 or q square, anywhere root symbol is present? No. Nowhere the root symbol is present in LHS condition. That means the entire value, it is clear that 8q square minus p square by 2q square becomes a rational number. But what can you say about root 15? Root 15 is not a perfect square. 15 is not a perfect square. So that's why root 15 is an irrational number. So how it is possible? LHS condition, we are getting a rational number. RHS condition, we are getting an irrational number. How can we equate a rational number to irrational number? Here also we get a contradiction. Why do we get a contradiction? Because of our wrong assumption. So here also we will agree the same. If we observe carefully here, LHS is equal to 8q square minus p square by 2q square belonging to a rational number, and RHS is equal to root 15 is belonging to an irrational number. So because of our wrong assumption, we came to know a rational number is going to equate to an irrational number. So this is a contradiction, which is a contradiction. So our assumption is wrong. Therefore, root 3 minus root 5 is an irrational number. Is an irrational number. Did you understand here? LHS condition is a rational number and RHS condition is an irrational number. They are never equal. But how they got equal? Because of our wrong assumption and wrong simplification. So finally we agreed our assumption is wrong. So that's why root 3 minus root 5 is said to be an irrational number. Okay, my dear students, today we have discussed about theorem 1.6. And based on theorem 1.6, we proved two questions. First one is show that root 7 is an irrational number, and second one is root 3 minus root 5 is an irrational number. So based on these two sums, I gave two problems as homework. So please note down today's homework. Show that root 5 is an irrational number. Nothing, simply I changed a number. There in our explanation, root 7 I have given. So here I changed a number. Instead of root 7, we gave root 5. Are you able to do this? Right, very good. Second one, show that 3 plus 2 root 5 is an irrational number. Did you understand both problems? Everyone, thank you. Thank you for today's class. Hope tomorrow we will meet again. We will continue the class for day 4. Have a nice day. Thank you to all.